Alright guys, as you probably can tell, I'm not here today. So we're doing these notes online, and I know last week on Friday we were all kind of in different spots here with our parent graphs, but I'm going to be graphing transformations of these parent graphs for tangent and cotangent. So I'm going to kind of show these parent graphs up here again. Now, I'm pretty sure I got through tangent with everybody. So the main thing I want to make sure you note, and you'll see me go through this today as I go through these notes, is first off the shape of your tangent graph. Again, a tangent graph goes through 0, 0, and it has that x cubed shape. It goes from negative infinity to positive infinity as you go from left to right. So you want to know again that it has that, the shape of tangent. You also want to know that it has two vertical asymptotes at negative pi over 2 and pi over 2, and it just repeats as it goes asymptote 0, asymptote 0, and so on. So again, just understand the shape and the location of your zeros and your asymptotes, and then once you know that and we start doing our transformations, we're just going to slide those points over, and if the period gets affected, we'll deal with that. Now cotangent, this is what cotangent is going to look like, and again, this is how I drew it out. Now again, if you can draw it out more or less, it doesn't really matter. Make sure you know this is one period right here. And I just noticed I could probably move my microphone closer here, so maybe that sounds better. So this is one period of your cotangent graph. Notice the difference on this one, two differences. First, instead of starting at 0, 0, your starting point is a vertical asymptote at your y-axis. And instead of going from the negative infinity to positive infinity, it goes from positive infinity to negative infinity. It's flipped, it's upside down. So know those shapes. Also understand how to find domain and range. You don't actually have to memorize the domain and range. You can kind of look at it each time, because it's usually going to be different when you do your transformations. It's just how you find it. And I'll go over that when we're doing our graphs. So this is the cotangent graph. If you don't have all that information, make sure you get that written down. Again, I will be checking the notes on this as well, so make sure you write, and again, just as a FYI, whether you know this or not, make sure you write all the notes. I want to make sure, really it's two parent graphs and two graphs, so it's not exactly that much work, but I do want to make sure that you did this lesson and you didn't just go straight to the homework and kind of guessed your way through it. We need to make sure we're doing the actual notes and understand them, because you will be tested on them this Friday. So we're teaching this now. This is the last lesson for this unit, but we're being tested on Friday. So it's super important you understand it, okay? So make sure you're getting this. So here we go. I got two graphs for you. I got a tangent and a cotangent. I'm trying to throw everything at you in these two examples. So I'm going to start here with tangent, and again, I'm going to go through all the same components each time: your amplitude, your period, your phase shift, your vertical shift, and your domain and your range. So as we do these, first off, just please know the amplitude is always going to be none, and your range, in this case, it's going to go from negative infinity to positive infinity, so all real numbers. So those are two quick things that we can get right off the bat. So another thing I can do, I'm going through my list here. I got my period. Now in this case, remember your period, there's an equation for period now. The period used to be 2 pi divided by b. Well, now the period is pi. So all we're really doing to this equation to find the period is we're going to go pi divided by b. Well, if we come back to this equation up here, the original, we have, starting off with a is going to be -1, which does flip our graph. We'll get to that in just a minute. But right now we're looking at b. b is 2. This one also has a value for c, and I do not have a d. If I put it there, it'd be +0, so that's my d value. So this one I'm going to have a period of pi over 2. Now, just like I did with the parent graph, please note to get the Patrick interval on this, it's going to be 0, asymptote, 0, asymptote, 0, asymptote. Now that pattern is going to be equal to half the period. That's how often it repeats. So I only need to take this pi over 2 and multiply it by 1/2, not 1/4, when I do tangent and cotangent. So that Patrick interval in this graph is going to be pi over 4. So that's going to be, again, I made it up, but Patrick interval is going to be, that's the distance on our x-axis that we're going to be traveling. That's the interval we're going to use, and it's going to represent the distance between all our zeros and our asymptotes. So that's that second piece. Now the phase shift, we do have a phase shift here. We are going to go, it's our C value, so we're going to go right C. Our vertical shift is none, and we'll do our domain after we have our graph. So I'm going to go ahead and put the graph or the xy axis up here. Again, I don't have to worry about labeling that y-axis. I only really need, I'm just trying to get that straight. Okay, I only need to worry about the x-axis on this one because we don't have an amplitude, so there's really not much to label. So when I label this, I am going to start at my starting point. And my starting point in this problem is going to be pi over 4. So let me go to that pi over 4, and again, my Patrick interval is also pi over 4, so I'm just kind of thinking this out. So here I go. I'm going to go to pi over 4, and as I said, my Patrick interval, or the distance between my asymptotes and my zeros on the x-axis, are going to also be pi over 4. So that makes the counting very easy here. So this is going to be 2 pi over 4, my next point, which is pi over 2. And then I have 3 pi over 4. And I'll just go out to pi. That seems good enough to me. And I'm going to go leftwards to the left a couple of points here. So one of those points is actually going to be right at the origin. And I'm going to go left one more, so negative pi over 4. There's really no limit to how far you go. It just makes me feel comfortable if I have that all written out there. Okay, so now that I have that, again, now you just need to know tangent. You need to know the parent graph. And the parent graph or tangent starts at 0, 0. So we're looking at this as my starting point. Okay, so that's really all you need to know, that and the direction. But I have the starting point right here at 0, 0. So I know right now that I have a vertical asymptote at my y-axis, because it's going to be 0 asymptote, 0 asymptote. We have that repeating pattern. And if I went to negative pi over 4, that would be a 0. So again, look at the pattern. We have 0, asymptote, 0. So next up, I have an asymptote, 0, and asymptote. So I can go ahead and graph this now. You just have to pay attention to one final little piece, and that final piece was this -1 that I had. That negative that went in front, so that flips my graph. So instead of looking like this, it's going to be flipped upside down, and it's actually going to look kind of like your cotangent graph. I mean, that's your cotangent graph goes in that direction normally. So it's going to have this look to it. And you just kind of draw it, however many of these you have repeated. I have kind of like 2.5 periods that I drew. And again, I only have half of this last little chunk off to the left, so I just draw half of it. And there's your graph. So you got your graph of tangent, and that's all you really do with it. And then you find your domain. So again, your domain, it's all real numbers except these. And if you want to write that out, that is one way you can do it. You can say, all reals except, you can write that out. I'm not going to do all of that, but it's all reals. However, you have these values here. X cannot equal, you don't need to write this, I'm just saying. Okay, but I'm putting it there just so you know. Alright, so you have all reals, but X will not equal, it won't equal 0. You don't even need to write that 0, I'm just putting it there so you know. Because 0 has an asymptote. So if X is 0, you got an asymptote. Now the next thing is, how far is it from that asymptote to the next one? Well, it's right in the number, right on the x-axis, so that'd be pi over 2. So it's going to be plus pi over 2k. And remember, k is an integer. Obviously, it's always an integer. And there is your graph. Now, you also, just so you know, and I think I put it plus or minus, you can do that sometimes, but technically, k is an integer. That means k can be a positive number and a negative number, so I can call k -1 and I'm going backwards. So I don't really need the negative, because if I call k a negative, it kind of takes care of that. So, I mean, not necessarily, it's not like it's wrong if the negative's in there, it's just redundant. So you can put the plus in there, plus or minus, I don't care. You can just have pi over 2k, I don't care. but you just need to have, again, all those other components. Okay, so there's your graph and all your information for tangent, and in a way it looks like this is a little bit less work. It's different though, so you got to kind of get used to those, especially when you have to do secant, cosecant, and tangent, cotangent at the same time, and they have different periods, so there is a different process to this. But there we go. So that is example A. Now we're going to go to our last one with cotangent. Now with this one, remember we have to set this up first. I don't have that b value factored out, so I'm going to go ahead and do that. So I'm going to have cotangent, and I'm going to pull that 3 out. And this is going to be x minus. Now if you want to remember what this is, remember I pulled out a 3. So I'm going to go pi over 2 divided by 3, which is the same as multiplying by 1/3. So I'm going to have my phase shift here of pi over 6. Okay, so just to show this one, because I don't have one on here, I'm also going to add a +1 to this graph. Hopefully you didn't do this before you watch the video. But I want to put a vertical shift in there, just so if you see one of those, you're not going to freak out like, okay, what do we do? So anyway, I'm going to go down the list here, find all my important pieces, just like I normally do. So I'm going to find my amplitude, my period, my phase shift, vertical shift, and domain and range. Again, some of these answers you already know, so you just kind of fill them in. There is no amplitude. I thought I changed colors there. Okay. All right, so you have no amplitude, so you just put none. Your range is all real numbers, so those are already filled in for you. All right, next up, your period. So remember, it's going to be pi divided by b. And I guess I'll label all those for you one more time. Remember, that's your a value, this is your b value, this is your c value, and that's your d value. So again, your period is just plain old pi over 3. It's pi divided by b. Also note that you're going to take this pi over 3 and times it by 1/2 to get your Patrick interval. So we got pi over 6. So there's your Patrick interval, which I'll need later. Your phase shift, you are going to go right pi over 6. So this one's kind of nice too. Looks like you're going right 1 Patrick interval. The vertical shift is going to be up 1, and we'll do our domain once we have our graph. So we are ready to graph. Alright, so just like I did before, just draw your XY axis. I don't really care about the Y axis in terms of labeling. This does have a 2. Now I will talk about what that 2 means, but it doesn't actually mean much, so we don't have to really worry about it. So I'm going to go ahead and label my first point at my phase shift. My phase shift is my starting point, which is at pi over 6. So I'm going to start counting by pi over 6s. Let's go out a few spots here. So my next spot here is going to be 2 pi over 6, so pi over 3. And then I have 3 pi over 6, which is pi over 2. And then 4 pi over 6, which is 2 pi over 3. Now I'm going to go to the left. If I go to the left, I actually do touch the y-axis. If I go one more point, I'm going to be at negative pi over 6, and that seems good enough for me. Now, this one does happen to have a vertical shift. So I do want to label that value on my y-axis up at 1, because that's going to be, in a way, kind of like that little midline. That's where your x-axis would normally be. So instead of labeling our zeros, we'll be labeling the points where your graph touches y equals 1, because those are going to be those points. They just got shifted up 1. So when I start labeling this, again, remember your parent graph. So we're ready to label. We've labeled the x-axis. We labeled the y-axis. All that 2 is going to do, which I'll try to show in my graph, is just going to go up a little bit faster. That's about all it does, and I'll show it to you when I graph this. But first thing I'm going to do, again, we're at our phase shift. We're going right pi over 6, and if you know your graph, you know that's a vertical asymptote. Otherwise, just look at your parent graph. It starts at a vertical asymptote, so we're shifting that vertical asymptote over pi over 6 units. So I'm going to draw a vertical asymptote at pi over 6. And that starts your pattern. So now you know it's asymptote 0, and so on. So let's go ahead and label those. Actually, I labeled my 0 in the wrong spot. Remember, we had the vertical shift. It's going to be up here. All right. So label it in the right spot, and then your asymptote 0, asymptote, and 0. And I'll do one more. This one, my scaling, it's all right. All right, so I got my 0 right there, which is actually again a y-intercept at 0, 1. Remember, I'm calling it a 0. It's actually not because it got moved up 1, but you get the idea. All right, so this graph has not been flipped. It just has a 2 in front, which means it just goes up and down faster. So instead of like leveling off like this, it's not really going to do that as much. It's going to be a lot quicker. So I don't want to overdo it either. So just trying to show that curve as best I can. It doesn't really get as flat. It's like it's being stretched from both ends, like you're pulling on these two ends vertically. It's just going up or down a little bit faster. So I'm going to, again, just trying to show that a little bit quicker. And same thing here, just a little bit quicker. It's not as flat as it normally would be. So that is your cotangent graph. Don't forget, you got a domain, so we are going to label that. So again, it's all real numbers except the ones I'm going to label here. You can put the all reals and then the except, or just write the equation. So this x cannot equal, and again, you start at any vertical asymptote. Here I'll pick negative pi over 6, or you can pick positive pi over 6, that is your phase shift. It doesn't matter. What does matter is this next piece. How far is it to my next vertical asymptote? Now there's two ways to do this. One way is to take these two numbers, which is at pi over 6 and negative pi over 6, and subtract them. So that's one way you can do it. If you minus a negative, you're actually adding these two together in this case. So that would be 2 pi over 6, which is pi over 3. The other way to look at it is the interval. This is basically one period. Well, notice this number matches that number. It's the period. That is the interval between your vertical asymptotes, and it always will be. So you can just say that the first asymptote plus the period times k. So both of these are correct. Obviously it's the same number, but you do need to state k is an integer. Or otherwise that wouldn't really be true, if you can call it like decimals and things like that. So that is your domain and your graph and everything else associated with it. So again, that's graphing tangent and cotangent. Obviously, because I'm not here, I will review any questions you might have during our block period, whether that be Tuesday or Wednesday based on what period you are. But here's what we do have for that day. In 5.4, we're going to do 3 more problems. So we're going to go to 5.4. I gave you odds. So that's actually 4 questions, not 3. But I gave you odd questions. You can check the answers. That doesn't matter when I ask for all the work. What I'm looking for when I see this is the work to find the amplitude, period, phase shift, vertical shift, domain, range. I want all of that. So make sure you're doing that, because the directions on the homework just say find the period and graph. I want everything I showed you in the notes. So you're going to have to add to that a little bit. But like I said, you have the odds, so you can go to your files and you can find the Blue Book folder and look up the odd answers. That will give you the graph and the period. It won't give you all the other stuff, but you can kind of check yourself. You also can use your graphing calculator. Make sure you're in radian mode if you plug this into your graphing calculator, and check the graph that way. You also have Desmos online. You can check that in any other graphing calculator app that you want to use. I want you checking this. I don't want you putting a bunch of wrong answers down thinking you're doing it right. And if you're still not getting it, again, make sure you have those questions ready to go so we can go over them in class. So go ahead and give these a shot, and make sure, again, we have time in class. Work together. If you can get this done in class, that'd be great. Work together on these. Work as a team, and learn. Help each other. Thank you.